Hello, the purpose of this video is to explain how to proceed with our schematics of the floor plan. So before we plan, we need to revisit our project requirements, and we know that this is a 24-hour cafe. There's a counter for ordering. There's going to be some display shelves for big goods. There's going to be some screens on top for the menus, and they want ample seating assignments with electrical. Wi-Fi is provided. They want to get it from they want to get their clients from local schools. They wanted a mix of quiet activities in some areas for socialization, and then they wanted to have a design where the exterior should be inviting. Obviously, they have a business, and then the interior should be designed that it acknowledges urban neighborhood setting. You know that it's located not in the wilderness or something like that. So they wanted something urban. So translation, they wanted modern. Okay. So client input, they wanted like they're open to a 5 foot or 10 feet setback. They wanted the indoor cafe of about 1,800 square feet. They want a checkout counter, 250 square feet. There's a vestibule for coats and umbrellas. There's a manager's office, 20 square feet. There's a storage, 20 square feet. They need restrooms, two restrooms at 50 square foot each, and that is subject to design requirements. That's what they want. Maybe the design will be less or more. Maintenance closet, 35 square feet. Electrical closet, 75 square feet. And then they wanted three parking spaces and a separate enclosure for their trash. So we consolidate that information. That's roughly 2,800 square feet of building. And we know that it's in a C2 zone with a special planning district that says that it has to be two 6 floors. It can't be one floor. Okay, so that means that the client needs an elevator, and then they need a stair. Okay, or stairs. Client is open to an outdoor balcony, so it's going to depend on your design whether you plan for an outdoor balcony or none at all or whatever. So it's your design. And we know that parking is not required, but the client wants three. Okay. And then if you provide parking, one of them must be ADA. And that parking should be the closest one to the door or entrance of the building. So one of that parking is A for ADA for disabled, and it must be van accessible. So there's two different options that we've discussed before. And then client knows that he has to provide some bicycle parking now in Sacramento. And then there's a 15-foot setback in the rear because it's a residential zone behind his property, and the maximum that he can cover is 70%. Okay. So once we revisit that one, that's very important for when you're trying to design your plan. We now have to look at the building code in detail, and we did that on our last step or last module. We classify the building. We know that it's an A2 uh, classification assembly group because this is for cafeterias or restaurants or whatever. We know that the building will be fire sprinklered because we have an occupant load that's 100. And how do we know? Well, if we have 1,800 divided by 15, I believe the net load, you're gonna have more. That's only for the cafe. You have other offices too, and whatever. Okay, so we know that it will be. And then the whole thing that triggers fire sprinklers is that you have a floor that can catch fire that is other than the level of exit discharge. That means if our exit discharge is the first floor, and then we have a second floor, then we have to have it fire sprinklered. Okay. Um, I have discussion. One of the students says that, hey, there's money's no rejection. This is a hypothetical project, but yeah, but we have to also talk about or do this like it's a real project. And in real project, the more non-combustible material you use, the more expensive it becomes. And so it's a cafeteria. Most likely, budget is limited, and most likely it will be constructed out of ordinary construction, which is your framing, 2x4s, 2x6s, 2x8s, wood frame, and so that's going to be a type 5. And That is typically how we do our construction here in California. Okay, if you're in Canada or something else, they do their construction very differently than what we do in California. And so we're gonna stick with a 2 by wood framing, which is a Type 5. And the reason why we put in a Type 5A is because of this fire rating. Fire rating, they have different classes: Class A, Class B, Class C, D, I think up to E. And Class A or B for the building code. What does it mean? Well, Class A means that it has some materials that is rated as I think not combustible immediately, right? So materials that fall into Class A include, things like chipboard, and they do not burn well, and they do not become like fuel to the fire. So their wood is a fuel for the fire, right? But if you cover that wood with chipboard, then you actually provide a barrier because they don't really burn. The paper will burn. Gypsum has paper, and the paper will burn, but because of the material inside, that it will not burn immediately. It would burn eventually, but there's some rating now. So Class A would be rated in terms of um, fire spread or fire penetration. Class B, that means that uh, it is subject to being combustible. Okay. So if you have a building and all the frames are exposed and you're not covering this up, then that's just called a Type 5. Okay. But if you cover it up with chipboard, then that's a Type 5A. Okay. So we're going to classify our building as a Class A because we're going to use chipboard to cover it up. The building height. Building height is going to be 70 feet max. And how did we know this? Out of this table over here, where the classification of A. And then there's several ways we can establish the building height without increasing the area. Our Type 5 is 70 feet. But if you increase the area, because there's ways to increase the area. If you have a small lot and you wanted something done, they limit you on the area. But you can increase that area by putting your building away from other buildings, having a very large setback in front, all that stuff. So, but if we don't increase our area, then we can go as high as 70 feet. If we increase the area, it's a give or take. If you increase the area, you lower the height of the building. That means you lower the number of floors that's possible. Okay. So in this case, if we don't increase the area, our height is 70 feet, which is um, relatively tall structure. 70 feet, tall structure. Now we do have a 3 floors maximum, and the reason behind that one is on this table in the building code. Um, our assembly is A2. We have a Type 5A, and without increasing the area, we can only do 3 stories. Okay. Um, but if we increase the area, it even goes lower to 2 stories. So we have a maximum of 3 floors max. But the more stories that we do, the more expensive the project becomes. We already we can't do a first 1 story cafeteria. We do have to have two stories, but 3 stories probably is out of question. Okay, so we're gonna probably do a 2 story. And here's your building code tables. So what is the allowable floor area? We can build up to 34,500 square feet. Okay, because if we have a Type 5A A2 assembly without increasing the height of the building, we're going to do 70 feet. So we're not increasing the height. Then we can do as tall as 34,500. If we do want to increase the height of the building, then we need to lower it to 11,500. So these things are uh, restrictions and what you can do uh, per building code. So if you want to, have a multi-story building that's bigger than 34,500, then you can't do a Type 5A, the simplest that one. You have to go to a timber or you have to go into some material which increases. And if you go to concrete, or steel. Steel would, if it's not the enveloping concrete, you can go only as high as 46,500 square feet for a steel covered thing. But if you have concrete, you can do unlimited area, right? So that's how the use is stable. So in our case, we can build as big as 34,500. That's too much. That's too big for a project. Okay. Occupant load again from building code. The cafeteria itself is just 1,800 divided by 15 net. So here's our table. Maximum floor area allowances per occupant. So we're going to do an assembly, cafeteria assembly, and we don't have fixed seats. So it's unconcentrated. That means you can move around tables and chairs. They're not fixed to the floor. In that case, it's 15 net. So that means that if we divide our cafe itself, 1,800 divided by 15, we're going to get 120 occupants just for the cafeteria area. Remember, there's an office, there's sort of a counter. So those are going to add up to the occupant load. Okay. So once we've classified our building with those occupant loads, and we can now say that hey, the first floor, uh, I'm gonna only have 900. Second floor, I'm gonna have not 900. That means that on the first floor it's 60, and on the second floor it's another 60 occupant load. So we have to do that number of floors later on for our design. Okay, so that's all about classification. And a lot of people think that hey, you just get pencil and paper and you can you know do your design, and that's relatively true for houses. If you want to draw houses or design houses, there's less restriction. But if you this is a business and you're designing or constructing a building that is open to the public, that is going to be subject to some requirements and strict requirements. So this is our introduction to using the Building Code in Americans with Disabilities Act. Okay, so we know that the floors, um, we're going to have two of them because it's a C2 zone with a special planning district, and urban design guidelines say we have two floors. And the effect of two floors is that we're going to have an elevator because we have to cater for the public, and the public sometimes is disabled, and you cannot discriminate from disabled and non-disabled. So in order for the disabled to go on top or the second floor, we have to provide the means for them to go there, and that's an elevator. And then we also have to have stairs, right? And stairs for normal people can be skinny, wide, tall, or high risers, but they might be people who are partially disabled, and we cannot discriminate, with partially disabled people. So the building code, because it's focused on safety and accessibility, will define how tall your threads are, how wide your stair should be, and whatever. Okay, so the number of stairs will be impacted by exits per floor, and we're going to look at that one next, because the number of exits, we need two per floor. And what dictates that one? If we have 1,800 square feet of cafe area, that's 120 occupants, and if we just put half of that one on top and half on the bottom, because there's no sense in building a second floor and it's not open, or you can't divide your um, cafe uh, with that one. So that means that yeah, it won't fit because remember 70% of our building, of our lot is can only be devoted for the building itself, and we have parking, and typically we only have I think 1,400 square feet in the ground floor, and that's not enough for 1,800 square feet of cafe. So depending on your lot plan, and that's why we need to do site plan first, to figure out the size of the building. And we did some projecting the square footage for the area of the building. So that's why on our last activity we added the square footage of the building. And on this design, with where some of you did this actually, the building occupies 1,400 square feet of the lot, and if we have a um, area for the for our cafe of 1,800, then the first floor itself is not big enough for the area of the cafe, because if you're doing only 1,400 square feet, uh, that's not even enough for the area of the cafe. Uh, so that means that we're going to have to split our cafe seating on the first floor and second floor. And because we have second floor, we have a stairs, and we have a stairs. How many exits do we need to have? Well, it says here on this table, 1006.3.3 is that if you have an occupant load of per story, that means for every level, you have 1 to 500, you have immediately two. Okay, so you have to have two exits. And because we have two stairs, then we have to now have. I mean, if we have two exits for each story, remember it says exits per story, then that means that we have to go down to the first floor from the second floor. That means that we're going to have two stairways. Okay, and those are things that the client doesn't know, but because the building code dictates that one, then we have to plan for two stairways. Travel distance is 250 feet, and this table over here in the building code, because we have a fire sprinkler system, it says that we can have a group A to have a maximum travel distance of 250 feet. You can increase that. There are some exemptions how to increase on the building code, but you have to do certain things before you can. But this one applies to us, 250 feet. Corridors, if we're going to like provide any corridors, like some offices would have a room on the left side and room on the right side. That means that there would be a corridor in between that corridor. It cannot be lesser in width clearance than 44 inches, and this is what dictates that one. Uh, the egress components, we have to multiply the occupant load of that floor by zero point 0.2 inch for every occupant. Okay. Um, Another table, though, would say that the minimum width shall not be less than specified in this table, though. So on this table, it's just that it's 44. So if you multiply zero point 0.2 by, let's say, half of 60, right? That's only like what, 18 inches, right? So 18 inches. Even if I go onto my side, I won't fit on that one because of my bulging tummy. But anyway, uh, there would be some minimum width required is 44 inches. Okay, so you can make it 48, and a lot of architects do. If they press for space, they would go to the minimum 44. But a lot of architects just use whole numbers for corridors, 48 inches. Okay, and that would lead us to the Americans with Disabilities Act, and I would have like a separate lecture on this one on Americans with Disabilities Act, because embedded in the building code is Chapter 11A and Chapter 11B. And Chapter 11B is about accessibility standards, which is all about the Americans with Disabilities Act. So they adopted the standards from the ADA into the building code under Chapter 11. And in Chapter 11, it's just the clear width, okay, is defined to be at least 36 inches, okay? But um, if you have an occupant load of 10 or more, then it becomes 44. So before, this wasn't 44, like long ago, maybe 1999 or something like that. This wasn't 44. But when the Disabilities Act was passed, it defined the width, and so they adjusted their minimums now, because it doesn't make sense to establish a minimum in the building code, and then the ADA would just negate that. Would just say that, hey, you need something wider. So they adopted. That's why building codes, like, they have revisions on it, and one of those revisions, and I don't know where it started, maybe in 2013 or 2012, that the width became 44 inches or something like that, or even earlier. Yeah, there is going to be a separate video lecture on the ADA, but it says here 44, so that's why we're adopting a 44. What about doors? Well, we're going to provide doors, and the door would have 32 inch minimum clear, and that means that the door has to be at an open position at 90 degrees, and the 32 inch would be the door stop. So it's not 32-inch door. Okay, and the reason behind that one I'll show in a minute. It says here that it's 32 inches clear, but the ADA says that the 32-inch clear, um, which is also here, says that it's 90 degrees, and here's just 32-inch clear. It is from the face of the door, and I think I have a bigger diagram here. 32 inches from the face of the door to the door stop. So here's the door stop here. Okay, the door stop. Oh, doesn't want to. Let's do fit. Yeah, it's fit. Yeah, so you can't specify the 32 inches because 32 inches is the clear space. So a lot of architects, they go with 36-inch doors. Okay, 36-inch doors, you know that the door itself, which is typically 1.5 to 2 inches, depending on whether it's a hollow core or a metal door or whatever. 1.5, 1.75 inches, even 2 inches, depending on, again, what finish you want there. Sometimes they put in a 1/4 inch plywood on that door, and then they have a core of one and a half. Just to be safe, architects in offices would have a minimum door of 36 inches that is used by publics and employees, because employees could also be disabled, and if you have a disabled employee, you can't hire them because you can't not hire them just because they're disabled, right? So if they keep capable of filling that position, and if they're disabled, then that means that the facilities that will house your employees must be accessible to the disabled, and that's why um, architects use 36 inches. So although it says here that it's a 32-inch minimum clear, they typically just use 36 inches. Okay, 36 inches. Um, and it also requires, and the ADA also requires maneuvering clearances. So if you're approaching the door, nothing must be obstructing the door 5 feet away from the face of the door, and 18 inches away to the edge of the door opening. Okay, if the door is, or if you're approaching the door and opens outwards to you, um, it should be 48 inches clear on the side of the door, and you don't need anything on the side. But if you're approaching the door and the door opens, you need to open the door by pulling it, then you do have to have this unobstructed space. Okay, and here all most of the diagrams for those different conditions. Yeah, so that's called maneuvering clearances, and it is from uh, Chapter 11B of the ADA, and which is integrated into the building code. Okay. Stairways. We know we're going to have two of them. How wide are stairways? Well, you can just multiply zero point 0.2 per occupant of the floor. Again, this could be very small, maybe 12, 16, 18 inches. But it's always whichever is greater, because 44 inches is the minimum as articulated here in 1009. Okay, it's a means of egress. And the stairway shall have a width of 48 inches, but it is not required for buildings with an automatic sprinkle system. So we're going to have 44 inches as a minimum. If our building does not have any fire sprinklers, if it's small buildings, maybe one story, then yeah, um, if you have a stairway going to like a mezzanine or something, then you don't need to meet 48 inches. If you have a sprinkler system, if you don't have one, then you do have to have 48 inches. Okay. Again, on ADA stairways, very very strict. Chapter 11, it says that the riser must have a height from 4 inches to 7 inches, so the max is 7, and the threads will be 11 inches minimum. Okay. Um, and then you can't put open risers. Open risers, we'll discuss that in a few. Maybe I can show you what that means. Open riser is a riser where stair where um, they don't have your foot could go into the in between the steps. So this is closed risers over here. These are open risers. Okay, these all of these are open risers. This one here is an open riser. This one's a closed riser. Your foot can't go in there. So here's a closed riser, and this one's an open riser. Okay, so that's basically what this one says. So again, I remind you that we have an occupant load more than 49, so we're gonna have two stairways leading to two distinct exits. And because we have stairs, then we have elevators. And so for elevators, we need a sliding door where the door width is 36-inch minimum, and you have multiple car size options. And again, there is a chapter in the building code, but mostly it talks about how you protect the elevators and all about mechanical. So uh, there's hardly any architectural there, except knowing that the construction of that one has to be particular, which is not in the design phase. But the ADA does dictate elevator types, and it says that the doors must be sliding, so you can't have a swing. So old European apartments, they have elevators where there's a door swing gate. Can't have that. Uh, Under the California Building Code, the only door that's allowed is sliding. Okay, and then you have options on how to locate the door, centered, side, and if you do, then if you want to center, then it's 42 inches. But if you put it on the side, it's only 36. Okay, and here are like different kinds of scenarios and minimum cab sizes or car sizes. So if you wanted the center door, you need 42 inches. But if you put it on the side, it's only 36 inches. And normally, a lot of people just use 36-inch side opening uh, because it's required. Okay. And so, what you now need to do before you do any planning is you need to get an elevator manufacturer to give you the cutouts. Cutouts is like details of the sizes for their shafts. Okay. ThyssenKrupp Elevators, German company, now known as TKE. They have this pretty neat website, and uh, that how to use that website um, is pretty neat. So let me show you how. This website, ThyssenKrupp Elevators or TKE, has several models here. And this one here says that the Endura MRL combines no nonsense functionality of hydraulics and a truly machine room-less design. So there's no machine room required anymore, but it will need more space inside because there's going to be some hydraulics. So let's use this. Let's click that, click next. And the good thing about this website from TKE is that it can actually give you some dimensions. So we can select from twin post above ground, twin post above ground, two stage. So let's just select one, and then we're going to do um, a speed slow, it's 80. And then you have several cab designs, and you have to select which one of your cab designs or which one do you want. Okay, so from our document here, if you wanted a center door, this is what it needs. And if you wanted a side door or off-center door, this is what you need. So 6'8", that's about 5'8", and 54, 51 here clear. That's about 4'2" or something like that. 4'2", 4'3". So going back to the website, you can select any you want, but I think this one will fit 5'8" by 4'3", so click that. And obviously we wanted something where it is on the side, so left or right, it doesn't matter. So let's click left. And then obviously we want a front opening. And when you do that, it'll say, "Hey, your drawing's ready." So close this and click this, and it should pop this up, and we can look at seismic drawings or non-seismic. You can even download a DWG file, but let's look at non-seismic. And then it will open this up, and when you open that, it'll tell you basically this is like the section that the elevator requires, and this is the elevator size inside and the hoistway. Okay, so if we look at this one carefully, it says that the clear hoistway, I'm sorry, 7'4", is required for this kind of elevator, and you don't need a machine room. Okay, and then the clear hoistway is going to be 5'9" wall to wall, and it's 7'4" clear hoistway. So that's again wall to wall installation. That's going to be rail bracket mounting surface. So whatever the rails are connected to, that's going to need to be 7'4" clear hoistway. Okay, so now you know the inside dimension, and you should be able to use that for your floor plan. Okay, now that we have the knowledge of the elevator shaft, which will aid you in your floor plan, we can now go to different things that would affect our schematic, like wall thicknesses. The walls, they are not all the same. Some are thicker than the others, and often um, those that separate occupancy or our firewalls are thicker. So fire separation distance is a distance set forth by the um, building code. And the definition of fire separation distance is it is a distance to the closest interior lot, or to the center line of a street, or to an imaginary line between the two buildings. So it's measured in right angles. Okay, so here's those three definitions. It could be here's the lot line, or here's the lot line, and the distance between the lot line and the building is your fire separation distance. Okay, so this would be your fire separation distance. If there are no lot lines, then the halfway point between the two buildings is going to be your imaginary line, and the separation fire separation distance is the distance between those imaginary line and the building line. Okay, so these are fire separation distance. If you are fronting a street or an alley, it's the center line of the street towards your building, and it's measured in 90 degrees. So here's the center line of the street. Therefore, whatever fire separation distance that is going to be your required distance. And so if you are encroaching, then that means that that wall have to be protected. And if those wall are not 90 degrees and it's not part of what needs to be protected, but it is still part of the building. So if your building is a 1 hour construction, then everything is 1 hour. Okay. So in our lot, here's 34th Street, which is 80 feet wide, and the alley is 20 feet wide. Therefore, this distance from the front of the lot to our center line of the street, that's the fire separation distance, and this side of the lot to the center of the alley is your fire separation distance. And um, we are talking about not the front of the lot, and uh, the this building was set back like 5 feet uh, for cafe, outdoor cafe, and that's just an idea. So on the second floor, this could occupy the whole thing, and so then the fire separation distance would be up to wherever the building is. Okay. Um, there is a table that talks about how to rate your walls. So if the fire separation distance is less than 5 feet, then the occupancy for the fire rating for occupancy A would be 1 hour. Okay, so all our buildings must be 1 hour. There are options that you can do because According to the urban form guideline for the Sacramento 2035 general plan for urban neighborhood, which we are, we should not have any setback in the front or side yard or minimal. Okay. So we can put our building up against the lot line on the side. Okay. And if we do, then there's no setback on the side, and that means that this building will have a firewall to separate the two. So that's a firewall. Now you can set that building back 5 feet, which typically is in houses. They're set back from the fence line 5 feet. And if so, the building we constructed is 1 hour, but now that you have access because you have 5 feet clearance, then you can put a stucco wall on it. Here you can't put a stucco wall because if there is a building here, currently there's none. So you do have imaginary access, but if you wanted to do some repairs on it, then you can't have access once the other building on this side gets erected, right? So it's not advisable to put a stucco wall on a side of a building. I don't think it's even allowed for UL testing. Therefore, you have the option of putting it set back, so you can have a stucco wall, which is cheaper to make because firewalls are expensive because they have a fire rating. Now, if you do set your building back, you might end up with a smaller footprint, which means a smaller building area. So you might need to adjust your building area to expand until you cannot, like the setback in the back. Then you have a setback in the back, setback on the side 5 feet, so you can have 1 hour rated stucco wall assembly. Okay, so those are your options. Um, Now, when you have a firewall, which is sometimes called the party wall, you will need to use a concrete masonry unit, which is rated to be 2 or 3 hours. Because stud walls with stucco on it is rated 1 hour typically. Okay, so firewalls is dictated in the building code, and for our occupancy A, the fire rating for a firewall is 3 hours. Okay, so there are 3 hours of CMU from different manufacturers. Here's one of them, Westbrook manufactures CMUs, and this one they come up with 2 hours and 3 hours. It depends on the aggregate and how porous the material is. But for this table under building code, we do have to meet 3 hours. However, if we have a type 5 construction, which we have, then that means that the wall shall be permitted to have a 2 hour resistance rating. So we don't need to meet 3 hours, only 2 hours because our construction is type 5. So we're going to use a 2 hour concrete block masonry unit. And the inside, because it's concrete, then it's gonna get cold. So we need to put some insulation and then cover it up with chipboard. Okay. So always check your area. If you are going to put a CMU on it, or if you wanted to uh, change your wall type that it affects your building area, uh, because it might be too thick in some cases. Okay. Now you still have to do insulation. So on it, even though it's a CMU wall. So let's talk about insulation a little bit. We Sacramento, in terms of climate, is zone 9. But for building climate zone, it's a zone 12. Um, so for wall insulation, which is defined not in the building code, not in part 2, but it's in part 6, which is the energy code. The energy code dictates insulation, and so for our project, which is a wood frame, the U factor would be should not exceed 0.110. Okay, so the U factor is the transmission of heat, like conductivity, from one side to the other. So if we have a U factor of 0.110, there's a equivalent R rating for that one. Okay, so for non-residential, which is our project, residentials are more demanding, more taxing because people live there, sometimes live there for 24 hours of a day. They don't go out. But for businesses, for commercial, it is only used for partial parts of the day, and nobody's supposed to sleep over there. So for our wall thickness on the firewall side, we can have a total 10 inch or 10 more, 10 inches and more on the firewall side, because we're going to have the 6 inches CMU, then we're going to have studs and put some insulation. So that insulation might take up like 4 inches. So if you have a 6 and 4, that will become a 10. And then you have the jig board, so you might end up with a 10-inch total firewall. So again, that affects 10 inches affects your room size, you know, because that's almost a foot. Okay. But for the other exterior walls, which is wood studs, you're gonna have stucco on the outside. There's some foam. Then you got some layers of waterproofing, and then you got your sheathing, and then you got your insulation inside. Typically, these are done with 2x6s for commercials. Even in residential now, they hardly use 2x4s anymore. It's now 2x6. So working with a 2x6 stud, and then with a G-board inside, we are required to have a R9 insulation on it, equivalent to that to a U factor of 0.11. Um, and then the R11 bat is an R9 insulation. So we're gonna end up with about 7 or 8 inches of exterior wall. Okay, so when you're doing your schematic, you got to think of how thick the walls are. On where you're going to put in your firewall, it's going to be thick 10 inches or more. Okay. Elevators. The elevator shaft can be made out of wood, um, or it could be made out of masonry. Since you already have masonry on site, you can have masonry. Typically, elevators are done with masonry, but if there are no other masonries in the construction, they typically don't want to bring in a masonry contractor into an all wood construction, because it just jacks up the price of the building, since you are bringing in a new discipline. So they want to stay with wood when it's everything is wood. But since we are required to have like a 10-inch CMU, I mean a 6-inch CMU on site, you might as well just also use CMU for the shaft again. But it's not mandatory. You can use wood. These shafts have to be rated at not less than 1 hour, and the TMUs, which are rated with 2 hours, will meet that rating. So um, this kind of CMU, which is rated for 2 hours, should be good with the shaft wall. Okay. Now, when you're doing schematics, you might also think where the windows will be. So windows are called wall openings, and wall openings are for doors and windows. Okay, and it has something to do with your fire separation distance we discussed before. If your fire separation distance is 0 to about 3 feet, and your building is sprinklered, the unprotected opening is not allowed if it's 0 to 3 feet. Okay, if it's 3 feet to 5 feet, you can only open 15% of it unprotected or protected. So unprotected and protected, it means that the opening, if it has a glass on it, that should also be rated the same as the wall. So if the wall is 2 hours, then the glass should be 2 hours. Okay. If the wall is supposed to be 2 hours and the glass is not 2 hours, then that's an unprotected opening. Okay. It doesn't have the same opening. In our project, we have a 0 fire separation distance. Then we have a 10 feet to the alley, because the alley is 20 feet. And we can open that up 45%, okay, unprotected. So we can open up 45% of the wall and just put ordinary glass there that's insulated, not fire protected. Okay. But on the front, remember that 34th Street, 34th Street is 80 feet wide. Okay. It's 34th Street and it's 80 feet wide. So if 34th Street is 80 feet wide, then that means that the fire separation distance is half of the distance to half of that one, which is 40 feet away, and that's 30 foot or greater. That means that we do not have any limit on how much we can open. We can open the whole thing, open the whole wall. Okay. So again, protected and unprotected. Unprotected openings is for doors and windows or anything that breaks the surface of the wall um, that has less than, okay, that has less than the rating. Okay. So for the wall opening, the front is unlimited. The alley side is 45%. You just have to remember that because this building is required to be insulated, then you still have to meet the insulation requirements of the energy code. Okay, so if it's a fixed window, then the U factor is 0.34 on a zone 9 or zone 12. If it's a curtain wall it's just all glass U factor is 0.41, zone 9 or zone 12. If it's an operable window, windows that can be opened, then it's a 0.46. And if it's a glazed door, a door that is not made of metal, made of wood, it has glass on it, then it has to meet a U factor of 0.46. And these U factors, since they're not built by the contractor, it is an item that the contractor will order from a manufacturer. The manufacturer has now the burden of meeting the requirements of the energy code. So they will rate their windows to be, oh, this one has a 0.34 U factor or 0.46 U factor, and all you have to do is use their product. So we don't need to think about assemblies and how to construct this because it's basically a plug and play. You buy the window, you install the window, and if you install it per manufacturer standards, then that becomes insulated per energy code. Okay. Part six of our discussion today will be about floor to floor height or floor to ceiling height. And we are just in the schematic phase, but we have to think about this one because how far up the next floor is, which is the floor to floor, affects our stairs. And the stairs affects the floor plan because the higher the ceiling, the higher the floor above, the more threads you need to put in, and the more threads, the more risers, or the more risers, the more threads, the longer we need for the stairs. Okay, so you need to do that. So you have to think about your floor to floor, and you have to think about your structure, and that's why the class is about architectural and structural drafting and design. It's because as architects, they take structural classes, and their knowledge of that structural classes helps them design the building that is structurally sound. Now that all of those calculations has to be verified by an engineer about dead loads and live loads and deflections and all that other stuff. But typically on a commercial project, we are going to use joists, and it could be a dimensional lumber, solid lumber 2 by 8, 2 by 10, 2 by 12. Longer than that one, I mean, taller than that one, we can move to an I joist. An I joist is it has like a 2 by on top and the bottom, and then the middle is plywood. It's OSB plywood. And then deeper than that one, we can use what we call an open web truss. Okay, it's basically 2 bys. It has like metal plates that fasten them together, and they take the loads very well because they are more efficient in design. Now, if you want to span longer, then you probably need to use a glue laminated beam. So glue laminated beam is made up of either scrap wood, and they mix it with glue, which is very very strong, very very strong. So because of that strength, it could span even longer. Okay, but you have to think that you think about the cost of the building because the longer the span, the deeper the joist, the deeper the joist, the more expensive the joist. Therefore, the project becomes more expensive if you do want it a longer span. So um, think you have to think of that way Uh, but if the owner is insisting that yeah, I want an open floor plan, or if you think that the best solution to what the owner needs is an open floor plan where the joist or there's no columns that can be seen as spanning from one wall to the next, then you just have to understand that it will cost more money because you're using um, more structurally sound material. Okay, so here is a manufacturer of those joists, and their product can carry 100 pounds per square inch or square foot. I mean, for the live traffic for people who's gonna come in and out, who's going to bring in some tables and chairs, desk or cabinets. The dead load, I mean, the weight of the joist itself is about 15 uh, pounds per square foot. And then how much do you want to space them? Well, if you space them at 12, an 11 by 7 and 8 can only span as much as 14 feet. The length of the joist is 16 feet, but the effective span is only 14.3. So if we wanted to like span maybe halfway, okay, that means that there's going to be a wall or column halfway because we have a 40-foot building width. Then we want to go with the 20 footer. Okay, so we can span that 12 inches, but we need to use a 16-inch frame or joist that has a total length of 22 feet, but can span 21 foot and 7. Okay, so that's what this one is saying. So this is how it's going to look like. It's gonna you're gonna see your 1 foot 8 or 16 inches, and then here's your web. You're gonna probably put some insulation on it, and then here's your ceiling material, and here's your floor material above. So that's gonna be part of the section. And then you now have to think of how high do you want the ceilings. Okay, so obviously you have an effect of grandeur if you have high ceilings. Okay, so you as the architect, you as the designer will have to decide how tall your ceilings are. So, and the reason why you want to do that is because you wanted to know how much run you have for the stairs. So we're going to do sections later, but for now, you have this conceptual understanding that hey, I want 12-foot ceilings. So 12-foot ceilings with about 24 inches of structure. That means that my floor to floor would be 14 feet. Some websites exist over there. Here's a calculator on the website where you can put in your total rise, which 14 feet is 168 inches, and the run, the thread, is 11 inches. The rise per step is 7 inches. Once you plug all of those, it will automatically tell you, hey, you need 25 steps. And those 25 steps needs a run, a length of 22 feet and 11. And once you know these two numbers, then you can certainly decide what kind of stairs you want to put. You want to put a stair straight. You can turn. You want to put just a landing, or you want to put some more steps on that turn. You can do a U, and you can do spirals. Okay, but whatever you do, we have to come back to it as a detail later. But the stairs run is important. The width is 44 inches. As we discussed earlier. Okay, so now you can do a floor plan knowing the size and requirements of the stair. Now, it doesn't include the landing. So when you go up the stairs and it's 22 feet this way, remember that there's a required landing on the bottom and you have to have a landing on top. Okay, that must be an unobstructed space. Okay, so that will be part of the ADA. Okay, so there's a lot of things we discuss in this lecture. Going back to what the client and the project is, classification of building, um, the heights and allowed areas and being sprinkled and everything like that, sprinklered. Then you got your first introduction to ADAs, right? Okay. Um, Door widths, although it says 32, yeah, architects don't use 32 because you got you don't know what the thickness of the door is because 32 is from the top to the face of the door. So they typically use 36 inches for commercial. We discussed that. We discussed required landing or unobstructed space. If you're approaching the door, there is a unobstructed clearance here. You can't put anything within that square. Okay. We talked about stairways, 44 inches, same as corridors, dictated all primarily by the ADA, and you need two stairways because you have more than 49 occupants on the second floor, so you need two. We talked about having two floors, now having elevator. We talked about the elevator shaft. We talked about the sizing. We talked about getting a cutout from the manufacturer. I gave you a website. Um, we talked about wall thickness because if we have a firewall, we talked about separation distance, and if you have a firewall, it's going to be thick, right? So if you have your building up against the lot line, then that's going to be a firewall. And if you set it back, you should make sure that you recalculate your area, or you might need more area than what you have designed so far. And firewalls typically are made of CMU, so that because you don't have access to one side, it's only your side you have access to. That means that you can't really do anything on that side if it breaks down or if it does anything. So CMUs are the way to go. But other walls, yeah, stucco wall from the outside. If you want to do all glass, sure, but there's going to be some parts that are going to be stucco because you can't open all of them, right? Talk about insulation. So that means that your firewall will need to be insulated. We probably have studs on it. Might end up with a 10-inch firewall just because of the insulation too. Shaft walls don't have insulation because they're already in the inside and can be made out of masonry or concrete masonry units. We talked about doors and windows opening. They must be insulated and how much percent we can open. No doors and opening on the wall directly on the property line is not permitted. On the alley, we are allowed to do a 45% of unprotected windows, but in the front, because it's greater than 30 feet, the fire separation distance greater than 30 feet, that we can open everything, no limit. Okay, so the wall opening, even though you put a window there, if it's part of the air conditioned space, then you have to put insulation as required by the energy code. Okay. And the last one that we discussed is about ceiling heights. Ceiling heights affects number of steps on the stairs. And so I gave you structure, um, lecture on structure. I gave you a sample here of manufacturer that says you can span half the width of the building if you use a 16-inch deep web joist, and that would look like this one. Now that you know that you got like a 24 inches or more than 18 inches of structure, then you have to think about your ceiling heights. And the taller the ceiling for commercial, for cafes, the better. But the taller the building, the more expensive. So you got to think of that one too. I gave you this website to figure out the total run for so that when you do your floor plan, you can plan your stairs and know how long. If you want to break it up and make a U stairs or even spiral stairs, this one, the spiral stairs is going to be more harder to do, but it sometimes it looks better. Okay. Uh, so in summary, with everything that we've done, um, we now can do our schematics. So in summary, after discussing the requirements of the project in part one, and then the classification of the building in part two, the design requirements demanded by the building code, and the ADA in part three, The types of wall, the assembly, the thickness, we discussed it in part 4. And then the openings and the door of the for the doors and windows, we discussed it in part 5. And the conceptual floor-to-floor height that we discussed in part 6. And after all those, taking everything into consideration, the designer, now at this point can now put on paper the floor plans or the schematics that he is thinking or she is thinking for the project. So um, most of the time, designers use tracing paper to layer over the different floor plans. So the schematics is a process. It's not like you sit down, I draw, that's final. It's a continuous improvement process. We call it revisions. And so until the architect finds the best solution. Now, this one doesn't get to be checked by your client. And in my case, it's not, I'm going to check your design. It's your approach to the solution and the knowledge of basically architecture, because you are not architectural students, but architectural structural drafting students, um, that we will leave this process just like you're doing the schematics the best way you can, the best knowledge you can for your clients. Okay, so this involves, laying out a initial floor plan, and sketching out with the aid of a scale rule. You want to do it like an eighth inch to a foot scale, and draw out the size of the rooms, locate the stairs if there are, and then once you've done that, you're going to step back and look at your floor plan and see what are the mistakes, improvements, or what are the things that you can change to make this a better solution, because you only get to construct this once, right? And so the construction has to be as perfect as possible, has to meet client requirements, has to meet building code, because if you go to the building permit section and the floor plans do not meet building code, then you have to revise it. And when you revise it, it will cost money for the person to revise it, for the drafting staff to revise it. So the approach must be the best and must meet all codes. Okay, so once you have one laid out, you might need to get another tracing paper, put it on top, and get another floor plan on it. Okay, and then again, continuous improvement, look at it, revise, make some adjustments, sizing, location, and in some cases you might need to like just totally do a revise, sketch again, and then from there, finalize floor plans until you come up with your final design with, and in your final design you must indicate wall thickness and everything like that. Furniture, something that, it's not to scale, but just to give you an idea of what you need to do. Okay, so again, it's a continuous improvement plan. It might take detailed drawings. Okay, I mean not detailed, but measured drawings. So you need to do a ruler and draw it out in a on sketch paper. Might take you to overlay another one and see, so you can see underneath what changes needs to be made, and then continuously look at your drawing or your floor plan, what needs to be changed, and it might be that you just need to restart again, put a new paper, white paper there, scribble in, make your floor plan adjustments until you get the correct floor plan, or the final floor plan that is best suited for your client. Okay, so that's a process that takes time. So you sit down, you floor plan, you do your schematic, and you pass it to your teacher because you did it only and spent only a couple hours on it. It will not be the best. So you need to like spend more time in it, and um, you want to provide the best for your client. So that takes repeated revisions, and so spend time on it. Okay, this is going to be your solution. It's going to be your final design layout, and down the road, you should only do some minor changes, not big ones, but very minor changes. But the overall solution should be there. So for your next assignment is to do your schematics. And when you're doing your schematics, lay out your lot. You don't need the backside or the rear because that's just part of the site plan. And if you have a tracing paper, then go ahead and put that in there. You will need to use your scale. And for floor plans, you probably wanted to use like an eighth inch. Okay. So where's my 8 inch? Here's 8 inch. And if I do that, that's my 40 feet over here. Okay. So that's 40 feet, 0 to 40. And so now is the time to use this. And if you wanted to do a 5 feet of outdoor cafe, the 1, 2, 3, 4, 5, that's 5 feet. Okay. So you're going to do a 5 feet cafe. Locate your stair. I don't know where you want to locate it. Um, let's say you wanted to do a 4 feet of landing. Okay. And you wanted a stair um, that's 44 inches. And you know that there's going to be like a 10-inch wall, right? So 44 inches is like almost 4 feet. And if I want that to turn, then I'm going to end up with 8 feet. 1, 2, 3. Oh, that's only 3 feet. So this is almost 4 feet. And then I wanted another 4 feet here. 1, 2, 3, 4. Okay. So I'm going to end up with a stair going like that. Here's the wall, right? And then this is 5 feet. So if there's a wall here, then I'm going to double line it. Okay. And then I have a landing, and then my stairs will take up 22 feet, I believe, right? 22 feet, and half of that one is going to be 11 foot something. So 11 feet is going to be here, 11 foot something. So my stair will end there, and that's my stair. You know, and I need 25 of these total, right? So 25, that means 12 and 13. And then I'm going to have another 4 feet landing on top here. Okay. So I might decide, hey, I want my stair to go from here and go up, go to landing and go like this, right? And so, and then I would want my elevator here. So this wall, which is 10 inches, is going to go right there. That's how thick it is. Okay, and then I have another 10 inch. I mean, not 10 inch, but 6 inch. And then I'm gonna have my elevator, which I believe is like 8 feet by something, right? So on my 8 inch, I lost my scale again. Okay, there you go, 8 feet and something, whatever that distance is from the manufacturer. Okay, so here's my 8 feet, and then I would have like 6 feet, I believe. Again, you gotta look at your manufacturer. And then it's gonna open to one side. So there's my opening. Okay. And so forth and so on. So you can locate the doors. The doors must be 36-inch minimum, but in cafes, um, you may want them wider. So you may want them to open here or in the center of the building or wherever. So if you want them to open here and you want them to be double, that's how to indicate that as double. Okay. Again here, it's not going to be 10 inches. It's going to be only like 7 or 8 inches. So you're going to do a double wall over there. And then now you're going to locate your plan, and you're going to locate your offices, your restroom, and everything like that. Okay. That's going to be your next assignment. We have to look at the ADA lecture. And I know this is already an hour, more than an hour lecture, but yeah, that's going to be your next assignment. Watch also the ADA to get an understanding of um, um, the dimensions required for restrooms. We did talk about the dimensions for corridors and doors as mandated by the ADA, part of the building code now in Chapter 11B. But yeah, uh, that's going to be your next assignment. Okay?